First of all, I'm really happy to be here and to present some idea about the soundscape ecology. I will try to speak slowly in my perfect Italian accent, okay? Well, what happened? Yeah, okay. I have approximately 40 minutes, so I will try to stay and respect the time in order to have questions after. First of all, I have to declare that the soundscape concept is not coming from ecology, but from human context. There is the Canadian School of Soundscape Ecology. Unfortunately, such people has used the term acoustic ecology, very inappropriate at the time, still inappropriate. But nevertheless, this is the story. There are different projects around the world since 16 by Schaeffer, for instance, capturing the information in urban area, in remote villages. So was a project of anthropology, like. So the differences between this way to interpret the sound and the ecological way to interpret the sound is quite different. But first of all, I will try to introduce you very simple concepts about the sound. You see here a Fringilla celeps. Nothing happened. No sound. What happened?
I think you just turned the sound off.
Okay, sorry, it depends by me. No. It's working very well before, and now it doesn't work. This is the trick of the... No.
This one?
It doesn't work. Okay.
Okay.
Okay. Wonderful. Too much. Too strong. Anyway, you know that sound is a vibration that travels through air or another medium at a speed from 331 meters per second in air and more in water. It very depends. The sound is represented at least in two ways, according to a peak enveloper and according a general or common spectrogram. Okay. This is a general spectrogram in which you can see the amplitude of the sound. Here you have the frequencies, and this is the peak enveloper that describes the sound in the totality. Okay, these are our tools. But moving into details, we are dealing with the acoustic information. For an ecologist, sound represents information. And the information is represented as the changing in the status along a frequency, along the time. And for instance, you can appreciate here a very complex situation. This is high informative point. Here is very low informative point. These are the patterns that we use to measuring the sound information, the acoustic information in the field. The patterns of the sound is very different according to the species. This is a cicadas. Pomponia imperatoria from Borneo. You can appreciate on the spectrogram the complexity of harmonics that are repeated regularly and created this such incredible sound. And this incredible sound can be analyzed according a complex, relatively complex index. I don't enter into details now, but you can see here the distribution of the sound along the time, and here the distribution of the sound according the frequencies. I present another example, always from the Borneo. This is helmet hornbill. Okay, you see, very regular, but regular sound, very simple in the low frequencies, low frequency, high frequency, along the time, some seconds, but the sound, the acoustic sign is increasing the relative frequency until finish with very accelerating way. Okay, this is nature, and this again, the representation along the time, the numerical representation, and along the time, along the frequencies. But entering more into details, you know, we know that animals are singing all together, and in order to avoid an overlap, try to subdivide and to partition in the acoustic space in specific areas. We call such the acoustic niche hypothesis. So the species use the same, the species that uses the same frequencies try to don't overlap. You can see different signs are different species that are divided according to the frequency. And this is the cartoon representation. I mean that species A and species B are singing the same frequencies. In order to don't overlap each other, they are singing at different time. But contemporarily, species A, species C, species D can sing together because they don't overlap according to the frequencies. This is an interesting story. We can see the high complexity of the sound in nature by elaborating the data that you have seen before, and these are 3D spectrogram from Borneo area, in which here you have a frequency beams and you have the time. You can see this landscape like mountains, like folds, valley, peaks, edges, etc., are or isolated island that is a singular species that is singing here to avoid to overlap with the others. So just an example, of course. But coming back to more the general idea of what means sound for people, you remember that Rachel Carson presented in Silent Spring a very important book about the use of pesticides that reduce the biodiversity, denounce earth degradation using sound. Or recently, Bernie Krause, an important recordist, worldwide recordist, celebrated biodiversity magnificence using sound. And of course, in this cartoon, we can say that we are auscultating the heartbeat. And this is an idea from Stuart Gage, a colleague from Michigan State University. And sound are really powerful proxies to auscultate our heart and to explore the relationship between people and nature. Is an extraordinary tool that is very underused until now, or has been underused until now. But we have to explain that often people believe or confuse noise with sound. What is noise? Noise is a simple and unwanted sound. Noise is noise. I'm speaking and I produce noise. I disturb you with this. This is noise. No, it's a sound. This is a sound. But people believe it's noise in some conditions. Well, noise. People is producing noise. Yes, unwanted sound. And this is a takeoff a jet. This is 120 decibel is a way to measuring sound. And you can imagine how many, do you know how many planes are contemporarily taking and landing every day in every part of the world? Amazing. We are moving everywhere, low cost, etc. No? So many. So this noise, what is the hand of this noise, of this energy? Is trashed? Is absorbed by who? By people, by trees, by rocks, and we receive an enormous amount of energy that must be dissolved. And moving again in a city is normal. And there are birds that accept or try to move away from these noises. And there is a very interesting story, because some species, like nest predators, corvids, etc., try to avoid noise, and some birds have advantages. So you have some birds in very noisy city because there are no predators, and they are more resilient to noise. But moving in more isolated area of the world, like in Alaska, you have such type of snowmobile. No, this is just the beginning. It's incredible noise. And this produces problems to elk, moose. They increase the stress of these animals, large animals, and can be measured. So we have a big problem of human sonic intrusion in protected areas. But we have also marine systems that are affected by noise, unwanted sounds. These images are popular in the distribution of ship movements around the world. And the effect of ship noise is dramatic, specifically on large fishes and whales. You know that a simple an advertisement of a ship. Okay, this sound is on the air, but the diesel engine produce noise in the deep waters, and you know that sound in water move faster 5 times than on the air. So there is a real sound pollution in the sea. This is a major problem for all this group of animals. So now a little of theory and epistemic information for you. You know that exists a landscape ecology, exists the ecological acoustic, bioacoustics, and now we have a soundscape ecology. I try to focusing on the soundscape ecology that is strictly related with the landscape ecology. And there are important components of the soundscape ecology that can be connected with the landscape. But before I have to define what is a soundscape. The soundscape can be defined as all sounds produced in a landscape and that represent the sonic environment for animals and humans too. So, if you see this image, you have echo by airplane, human voice, bird, wind, waves, etc. So the soundscape is the result of processes strongly affected by structure and dynamics of geographic landscape. Pichanowski et al., a paper that we wrote some years ago. Everywhere, every location, habitat, territory, etc., ecosystem, the landscape, have a specific, peculiar soundscape. Also in this room, there is a peculiar soundscape in this moment. It's my voice, your silence. It's exactly. If I stay silent, we can understand the sound outside. Otherwise, my voice is perceived by you differently according to your position in this room. So we have at least 3 types of sources, of sound sources: geophony, biophonies, and anthropophony, that I call technophonies. So geophony is the production of the wind or waterfall, etc. Biophony is the voice of animals, human too. Anthropophony or technophony is the noise, the sound produced by technical devices, car, airplanes, etc., etc. So some example for you. This is the melting ice, the sound of the melting ice. Air bubbles of the smelting ice. So in the Arctic, you have such a type of noise close to the coast. It's very important for animals. But moving in very more trivial areas, like maybe, an area. This is the noise of wind. You see that this information for a soundscape ecologist is absolutely important, because it's covering the voice of the animals. But moving in the more rural and human-oriented area, this is the sound of birds from this tower. Is exactly this tower, is not an artifact. This is sound from the Rucola Castle close to my home, in which I have here a recording system to collect information about the swifts, Apus apus, that is breeding in these holes. So this is not an artifact from internet. Okay. And this is another noise. This is ape, bee, that is passing through. Okay, my time is moving very fast. Okay. People. In Potsdam, last year, during a coffee break, in a small room with 100 people, the sound, not the image. So, Germany, voice, your voice. True, it's true. And now, Madagascar, cicadas. And Here, other animals, are other animals. This is cicadas. Are covering completely the spectrogram. It's natural noise, okay, for people, maybe natural noise. And we have also other example. Here we are in, oops, it doesn't work. Yes, are fishes. Fishes. Incredible. Other fishes. Fishes. And finally, you expect that the sound is music. A down chorus of birds. Turdus merula, blackbird, or robin, maybe. So, the soundscape ecology is an efficient tool for describing complex phenomena at community, ecosystem, and landscape scale within natural and human-dominated system. So, the advancement of such a field of research is well documented in this last year, thanks to publication, books, etc., etc. And we have publication in paper like Bioscience, Landscape Ecology, Ecology Informatics, Bioacoustic, Journal of American Society of Acoustic, Science, finally Science. So it's very popular. It's coming very popular. And we have the results of the last Paris meeting, just in June, and I am here in the center. Definitely I am a boss of this. No, that's true. And I organize with Jérôme Suer here the meeting. Other collaborators are here from Australia, from Spain, from Italy, etc., from USA. Okay. And finally, in the next year in Portland, Stuart Gage and I, we organize a new meeting connecting the soundscape to the landscape. So, coming back on the relationship between landscape ecology and soundscape ecology, and you can see this is a typical Italian landscape, mountain landscape with edges, open fields, woodlands, and this is German landscape from internet. I'm sorry, I don't know where is part of Germany. Well, you know, and here there are landscape ecologists, that the landscape, the geographical landscape, is characterized by shape and size of the objects, edge complexity, spatial distribution, patch diversity. These are some of the ideas that are in the landscape ecology. So I will try to connect these two approaches. What is the relationship between landscape and soundscape? Oh, well, there are several models. It's surprising that the landscape and the soundscape are not coincident, and that the soundscape has more detailed information than the landscape. So the soundscape has a final resolution, absolutely a final resolution. So we have at least, I'm sorry, this is a very specific topic. I try to simplify. We have at least 4 levels about the sonic object: sources, spatial overlap of the sources, behavioral processes, and landscape processes. These are the 4 epistemic domains. And now in this graphic, you can see that you have geophonies, biophonies, anthropophony, as I have described before, that are overlapping at the landscape scale, and they produce a situation that I call sonotope. These are the units, the sonic units created by the overlap of geophony, biophony, and anthropophony. But the story is longer than we believe. If I add behavioral processes, for animals of course, we can distinguish inside this sonotope subunits created not by physical feature, but by the behavior of animals. I call such subdivision sound topes. And finally, if I use the theory of landscape ecology, if I had landscape process like ecotones, I have another category of objects, of sonic objects, that are the sonotones. So 4 categories, according the source, according the type of overlap, and finally according to the spatial resolution or displacement. Here, sonotone, sound tops, sonotopes, and finally sonotones create such type of complex figure. So, in other words, the sonotones are an additional complicans of the sound tops, and the sound tops are an additional complicans of the sonotones. Of the sonotone. The edges, at the edges, you know, you have an habitat more disturbed, etc. So we can expect some changes in biophony or in geophonies. And if I see more in detail what happened, this is a satellite images where I can find the sonotones between 2 different covers, land cover like pasture or shrub or forest, etc., etc. And this is an interesting field of research, because we know that according to the ecotones we have a different distribution of frequencies inside the soundscape. So the soundscape is different according to the position in which you are collecting this fact. And we have scientific evidences from, for instance, from this work of Tucker et al., appeared recently on Landscape Ecology, where anthrophony, geophony, and biophony have been investigated, and we have seen that the increasing the patch size of the landscape, we have a different behavior of anthrophony that are reduced or biophony that are increased. This means that more fragmented is the area, more anthrophony we have, more is homogeneous the area, more biophony you have. This in general. Maybe that something doesn't work in this way. But again, if I use the sonotope as an example, these are different distribution of biophony, geophony, and anthrophony. Well, these are different cases of sonotopes, and if I investigate one part of this sonotope, I can find differences according to the place in which you are. So are emerging the sound tops created by different arrangement of species, a different arrangement of the communities. I'm sorry, I don't know if this is enough for you for the first time, but according to this epistemology, we can collect information, and we can see that according to the season, in the same area, you have a different acoustic scenario. You can see the time of the month, and every day you have a different scenario produced by, in this case, by birds that are changing patterns, acoustic patterns, according to the phenology of the season. So a very complex situation, where I use the semiotic approach that I prefer. I put the species at the center of a time and space and perception box, in which there is also culture, and I use this epistemology to explain what I collect. And we have big evidences that the landscape patterns, like fragmentation, affect the typology of the sound, for instance, in Dupont lark or in skylark. And we have other interesting point of discussion. We can distinguish in a soundscape a far field and near field, according to the amount of energy that we collect on our recorder, in our recorder like this, okay? And we know that birds, particularly birds, are the capacity to ranging. In other words, they can judge the distance at which the other individual are, and the behavior can change accordingly. In this case, there are no problem because the other male that is singing is far, but in this case, this bird is in trouble, like in football play. When the player is far, the ball is far, no problem, no? When they are approaching, the problem is rising. Just an example, in the morning, early morning before the sunrise, every vocal animal are very active. We call such phenomena dawn choruses. Dawn choruses, this is in the morning, the first birds in this case is singing, and approximately in 50 minutes in springtime there is an incredible amount of energy, of acoustic energy that is produced, and we don't know, there are 12 hypotheses. I don't explain no one of these hypotheses, but any one of these hypotheses, but there are many hypotheses about this interesting phenomenon, the chorus phenomenon, that has been studied by since a long time by Leopold or by Griffin, and they have discovered that the chorus is important for the communication of animals, as is important also for informing other animals. For instance, in this cartoon, the frog chorus is used by migratory birds for orientation. The choruses occur in the morning, early in the morning, and there is two peaks, the morning and the dusk, and is one of more intriguing phenomena in which on which we are working actually. For instance, we have discovered that moving from highland to lowlands, the importance of the choruses decrease. It means that the choruses is very distinct phenomenon when there are few resources, like on mountains, and this phenomenon is reduced when there are high resources. It means that after the 50 minutes of the choruses, birds specifically are not silent, but they are singing more or less like in chorus time. And this is an important topic to be on which to focus. But coming back to more general discussion, the soundscape can be used to assess and monitor the environment. You know that the environment is affected by many facts, many events, by humans, of course, and we can use the sound as indicator of what happens in this environment. This is a study carried out by colleagues from Switzerland on the sound of the stream. It seems very strange, but it functions very well to characterize the stream, the regime of water flow. Or you can summarize all data of 1 year, for like in these cases, or in some months, sorry, in these cases, in this case from May to July, and you create such a fantastic landscape, soundscape. In reality, these mountains are the dawn choruses, these are cicadas during the day, and this is the dusk choruses. So you have an idea how is distributed the sound, and you can produce, like in GIS facilities, these maps of distribution of animals, of the sound, of the song of animal in the study area. But of course you have to use a matrix of recorder, not just one recorder. Also in marine area you can apply the soundscape studies. I have no time to enter into detail, but are very interesting studies carried out recently using the acoustic complexity index that I explain later. How to measure in the soundscape? Okay, this is another important story. We have now innovative acoustic and efficient metrics that allow to manipulate the acoustic file. And these offer a lot of advantages for people, for researchers, because lack of the disturbance by operator, permanent storage in acoustic file post-processing, long-term recording, hours, days, weeks, months, seasons, years. So we have different approaches. We can collect automatically. We can have direct oral procedure and interpretation. We can use a public interview. For instance, if I devote my research to social direction, or you can measure the sound pressure using sound level meter, or you can use spectral measure, digital recorder, and this is the field in which we are in this moment, and we produce different indices. I don't enter into detail for indexes, but there is free downloaded for software for analyzing the data, like a C-Wave, that can manage the data, the acoustic data, or you have other, this like mine, Soundscape Meter plugin are free. You can download these and you can apply. There are different metrics. I present you just one metric. I imagine that for you is just a formula, an equation, but nevertheless, with this equation, I can measure the information, the acoustic information, because using this approach that now is quite standardized, I'm measuring the information, such I mean the peak, the difference in peak along every frequency in which I can distinguish the sound. And I can produce images like this. In red, the morning activity of birds. In yellow, the down chorus, and you can measure it directly this. You can analyze the data in different ways, different scale, day, hours, etc., etc. And you produce this that you have already seen. This is more sophisticated figure, all the day, all the year long. For instance, here is the frequency, the low frequencies. That means the geophonies along in one station for 1 year in the Mediterranean Maquis in Cinque Terre. I believe that some know where is Cinque Terre, close to La Spezia, and this is the amount of energy produced by biophony. This is an island in an ocean of noise, in this case, and you can see that the majority of information about biophony is exactly where you have green here, and the second island is in autumn, and etc. So I have 5 minutes. See, I see more or less. I try to conclude. We have a lot of new scientific facilities, like this small miniaturized low-cost recorder from $10 you can record, or more sophisticated recorder like this hardware in which we are engaged for the production. But sound is not only music, is also vibration, vibration used by reptiles to capturing prey or to transferring long distance information, like elephants that are producing by stamp noise, that sound that can be traveled until 32 kilometers. We can use, for instance, for attracting worms, grunting. This is a special game made in Florida, attracting worms outside the soil. Interesting story. Insects are producing vibration, like hands, and we can measure in vibration of the soil, and you can depict a creative map of distribution of pest disease for land. There are different figures about the sound of organism, of such type of organism. I move very, very quickly. And finally, there is a very interesting part of the story devoted to individual and social human dimension of the soundscape. It's not my field of research, but you know that people produce or is sensitive to sound produced by car, by airplane, etc., etc., and we have problem relatively to this fact. We have a physical level, perceptive level, interpretative level, and there is a real important field in which we can describe every type of sound according to human point of view. We can appreciate the level of annoyance living, for instance, in the city, and this is different elements that can create annoyance in people. We can test this using visual and acoustic experiments. And finally, I conclude in time 2 minutes, and I say there are no conclusions. We are in a new field. We have enough theory, but we have a lot to do in front of us. So we have new theories like SoundTop, acoustic niche. We have new tools like SoundMeter, Soundscape Explorer, etc., etc. We have new metrics, and we have new researchers in landscape, in seascape, and we have amazing possibility to apply this new science in environmental monitoring. So finally, soundscape ecology is absolutely promising, a promising discipline. Can be used to monitoring threat of animal communication, long-term soundscape monitoring, protection in national park, etc., etc. Finally, and is not a secondary, soundscape ecology can be applied for inspiring art. Fragment of Extinction is a recent work made by David Monacchi that used the sound from primeval forest to create symphony and copying animal to symphony. The last is not really the last, as the last, but okay, this last. I think I am a teacher, and I think that our mission is not only to be a researcher, but also to educate people to appreciate the sound. Because if you understand what the sound say, means you can protect nature and ourselves. So this message is for biologists, for ecologists, landscape ecologists, architects, environmental engineering, urban planners, wildlife, park planners, etc., etc. This is my booklet that is devoted to education, and my offer to open in your curriculum a small part, or devote a small part of your interest in the analysis or in the study of the sound, because sound is part of our life, absolutely. You are moving in the tube, you are moving in the airplane, you are moving outside the city or in the nature, everywhere. Sound is coming, you can close your eyes, but you can close your hair. It's difficult to close your hair. And so sound is moving around us, around you continuously. And why we don't use this information for improving our lifestyle and protect our environment? This is my question. So I encourage you to enter in this new field. Okay? Thank you.